In this lesson, we will apply trigonometric identities to solve the following problems. Let's get started with the first one. In the first problem, we are required to prove that sine 2 theta is equal to 2 tan theta over 1 plus tan square theta. 1 plus tan square theta. We are going to start with the right hand side. Right hand side is equal to 2 tan theta over 1 plus tan square theta, and replacing tan theta by simple trigonometric ratios in terms of sine and cos, we have 2 sine theta over cos theta, and then divided by 1 plus sine square theta over cos square theta. And if we take LCM in the denominator, we will have 2 sine theta over cos theta divided by cos square theta plus sine square theta divided by cos square theta. And now we can reciprocate the denominator. We'll have 2 sine theta over cos theta into cos square theta divided by 1, because cos square theta plus sine square theta is equal to 1. So now we can cancel out this cos with the square, leaving behind 2 sine theta into cos theta, which is equal to sine 2 theta, and that's what we are required to prove. That is what was required. And now the next question, question number 2. For second question, we are required to prove that cos 2 theta is equal to 1 minus tan square theta. To show that cos 2 theta is equal to 1 minus tan square theta over 1 plus tan square theta. The trick in the proof of these trigonometric identities is that we just take a look on the side which is more likely to be simplified, and then we continue to simplify it, and it just flows like water until it gets equal to the other side. So now we are going to take right hand side. Right hand side is equal to 1 minus tan square theta, 1 minus tan square theta over 1 plus tan square theta. Replacing tan in terms of sine and cosine, that will give us 1 minus sine square theta over cos square theta, and in the denominator we will have 1 plus sine square theta over cos square theta. Now we are going to take LCM in the numerator and in the denominator. So this will give us cos square theta minus sine square theta divided by cos square theta, and in the denominator we have cos square theta plus sine square theta divided by cos square theta. So this will give us cos square theta minus sine square theta divided by cos square theta time reciprocating the denominator, this will give us cos square theta divided by 1, because again cos square theta plus sin square theta is equal to 1. So cos square is cancelled with cos square, and we are left with cos square theta minus sin square theta, which by formula is equal to cos of 2 theta. So the next question that we are required to prove is question number 3. What we have is, we want to show that 1 plus sin theta, or 1 plus sin A divided by 1 minus sin A, 1 minus sin A square root is equal to sin A by 2 equal to sin A by 2 plus cos A by 2 plus cos A by 2 divided by sin A by 2 minus cos A by 2. Let's take left hand side and start simplifying it, keeping in mind what is that we want to prove. So left hand side is 1 plus sin A divided by 1 minus sin A square root. It's always, your eyes must be on what you want to prove. Now I can see that half angles are involved on the other side, so I need to simplify this side in terms of half angle. Therefore, what is coming into my mind is that I should replace 1 by cos square A by 2 plus sin square A by 2, because that's Pythagorean identity and it's always equal to 1. And then plus sin A, I should apply half angle formula. So this is equal to 2 sin A by 2 into cos A by 2 divided by, similarly here it is cos square A by 2 plus sin square A by 2 minus 2 sin A by 2 into cos A by 2, and everything goes under the square root. And remember that sin A is double of the angle of A by 2, sin 2 times A by 2, and you can apply this formula on this, 2 sin A by 2 cos A by 2. So this is what we have applied here. And now if you take a look inside the denominator, this is sin A by 2 plus cos A by 2 whole square, and in the denominator we have sin A by 2 minus cos A by 2 and whole square, and then there is square root above everything. Square will be cancelled with the square root, leaving behind sin A by 2 plus cos A by 2 divided by sin A by 2 minus cos A by 2. So this is what is on the right hand side. equal to right hand side. And now the next one, that's probably number 4 question. And for number 4, given that tan alpha is equal to 2, and clearly tan alpha is equal to a positive number, and also it is given in the question that alpha is not in the first quadrant. So here, if you take a look on the question, it's given that alpha is not in the first quadrant. And if tan is positive, it could be either first quadrant or it could be the third quadrant, because here it's A, S, T, and C. Tan is negative in second as well as it's negative in fourth quadrant. It could be only positive either in first or in third. So if it is given that the alpha is not in first quadrant, then for sure it is in third quadrant. Since alpha is not in first quadrant, clearly it is in third quadrant. Clearly alpha is in third quadrant. It is very important to know which quadrant the range of the angle lies, because that's what will tell you the sign of other trigonometric ratios. Now also given that tan alpha is equal to 2, which means that for a right angle triangle for which this alpha is defined, here if this is alpha, this is opposite and this is adjacent and this is hypotenuse. We know that tan alpha is equal to opposite over adjacent. Since tan alpha is equal to opposite over adjacent, this means tan alpha is equal to 2 over 1. So if this is equal to 2 and this is equal to 1, then we can find hypotenuse by using Pythagoras theorem. By using Pythagoras theorem, hypotenuse square is equal to opposite square plus adjacent square. This means hypotenuse square is equal to 4 plus 1, or in other words, hypotenuse is equal to square root 5. So once we have found that hypotenuse is equal to square root of 5, we already know that the alpha is in third quadrant. Now we can find sine alpha, which is equal to opposite over hypotenuse, mean 2 over under root 5, and it's negative because if alpha is in third quadrant, sine is always negative in third quadrant, and in third quadrant cos alpha will be negative as well, and its value will be minus 1 over under root 5 because cos is equal to adjacent over hypotenuse. So now you have these three trigonometric ratios. You can find out what is value for sine 2 alpha. So here number 1, sine 2 alpha is equal to 2 sine alpha into cos alpha, means 2 times sine alpha is what? Sine alpha is minus 2 over under root 5 into cos alpha is minus 1 over under root 5. This means this is equal to 4 over 5. So that's the value for sine 2 alpha. And now if we want to find out cos 2 alpha, cos 2 alpha is equal to cos square alpha minus sine square alpha by formula, and cos alpha is equal to minus 1 by under root 5 square minus negative 2 over under root 5 square, which means this is equal to 1 over 5 minus 4 over 5. The answer is minus 3 over 5. And now if we want to find out tan 2 alpha, tan 2 alpha is equal to 2 tan alpha over 1 minus tan square alpha. And this was alpha. It was given that tan alpha is equal to 2. Therefore, this is pretty simple, that 2 times 2 divided by 1 minus 2 square is equal to 4 over 1 minus 4. This is equal to 4 over 3, negative 4 over 3. So this is value for tan 2 alpha. This is how we can simplify any trigonometric identities if we know what are the basic trigonometric identities, half angle trigonometric identities, and double angle trigonometric identities.